Welcome to this segment of Zenith's In Focus Sales Training Program. The purpose of this program is to explain what head count really means in terms of video and audio performance. Customers who understand the value of added performance will be more likely to want that performance in the Zenith products they buy. To really understand how head count relates to performance, let's examine how the video signal is recorded. We'll start by taking a look under the hood. When a tape is inserted, this is the path the tape takes around the drum. You'll notice that the transport wraps the tape a little more than halfway around the drum. It's this threading process that brings the tape into contact with the tiny video heads used to record and play back picture information. Now, what we're really interested in here is the main head drum. This is where the head count takes place. Now, it's kind of hard to see, so let's take a look at an enlarged version of the head drum assembly. Now, the heads we're talking about protrude from the drum. Now, as the tape moves around the drum during recording, the heads lay down a trail of magnetic patterns or picture information. To understand how these magnetic patterns are made on the tape, we need a graphic illustration of how this process works. Our illustration comes in the form of this model, which is an enlargement of a piece of videotape. Each of these diagonal tracks represents picture information recorded by a video head. Notice that adjacent tracks are at different angles, commonly called azimuths. Now, this happens for all the tracks, but we've only illustrated it on these few. Now, each colored track represents one field, and it takes a pair of these fields to create one frame of video. These frames are the electronic equivalent of frames of movie film, except you won't see a picture by holding videotape up to the light. You won't see the diagonal tracks either. Recorded videotape contains 30 of these frames, or 60 fields per second. Now, to better understand, let's go back to how the signal is put on the tape. The heads are little electromagnets that lay down the fields during recording and read the fields during playback. To help illustrate what this means, let's take a look at a head drum layout. Now, in this two-head example, one head is angled to record and play back the first field of each frame, while the second head does the same for the second field. Now, the reason the heads are set at different angles is so the information in one field won't interfere with the information in the adjacent field. And since it takes two fields to make a full frame, you can see why a minimum of two heads are necessary for recording and playback. Now, keeping the two fields per frame concept in mind, let's take a look at the playback of a two-head machine. And just to make it interesting, let's see how two heads perform in various playback modes with tapes recorded in both the SP and EP speeds. During normal playback, there is little difference in picture performance between SP and EP speeds. But in special effects playback modes, such as speed search, the noise bars in the SP picture are more pronounced than in the EP speed. The difference is much more significant in the pause mode. That's because in a two-head design, the head width is optimized for the EP speed. We'll talk more about head width and recording speeds a little later. This demonstration has illustrated that two-head machines generally involve performance compromises, especially in special effects situations. But for now, just remember that two heads are the minimum necessary for video recording and playback. Some machines feature a third head. Now, in terms of normal recording and playback, three-head VCRs are no different than two-head machines. The difference occurs with special effects playback. That's because the third head is a kind of helper head that kicks in for special effects modes such as speed search and pause. Now let's compare the picture performance of a two- and three-head machine. First, EP. Let's look at forward speed search. Now in SP. Now pause in EP. And pause in SP. The difference is dramatic. The noise bars on the 3-head machine have been virtually eliminated. Notice that the 2-head VCR's picture shows a little movement or jitter. That's because it's reading the action of 2 different adjacent fields. But the 3-head picture is stable. That's because the 1st and the 3rd head have the same azimuth angle, which allows the same field to be read over and over. This use of an odd-numbered helper head also applies to the 5-head machine. Like the 3-head machine, the 5th head provides added picture quality in special effects playback. To understand the performance of a 4-head VCR, it's important to remember that 2- and 3-head VCRs are optimized for just one speed, EP. To optimize performance in both speeds, a second pair of heads must be added. So, the design of a 4-head machine is not simply the result of adding another head to a basic 3-head machine. Rather, it's the result of starting with a 2-head machine and then adding a second pair of heads specifically for the SP speed. Now, to better understand what it means to optimize performance for each recording speed, let's go back to how the signal is put on the tape. Now, these broad tracks represent fields of video laid down at the SP speed, and these narrow tracks represent fields recorded in EP. Now, the reason for this difference is fairly simple. In SP, the tape moves past the heads at a faster pace than it does in EP. So, by matching the head width to the SP tape speed, more picture information can be recorded. Now, by comparison, in EP, the density of the tracks is tripled. So what this means is, in a 4-head machine, head width and track width are matched in both recording speeds. Now, let's see what this looks like on the screen. First, we'll compare special effects playback performance in the 2- and 4-head machine. In speed search, in the EP speed, the differences are barely noticeable. Speed search in the SP speed, however, clearly shows the result of having an extra set of SP heads optimized for that speed. This improvement in performance is also apparent in the pause mode. This is EP, this is SP. So improved performance is based on the fact that a 4-head VCR uses a separate pair of heads for each recording speed. Now, this clearly pays off in the SP speed, where the wider heads can accommodate more picture information. And the more information recorded, the more picture there is to play. There is one important variation in the design of 4-head VCRs. It's called double azimuth. Now, sometimes the double azimuth name is applied to 3-head VCRs, but as we'll see shortly, the true benefits of double azimuth performance are best demonstrated in the 4-head design, as used in high-end Zenith products. Now, this head design provides the same basic performance as a normal 4-head machine, but double azimuth heads do provide some important improvements in special effects playback, too. So let's take a look. An easy way to demonstrate this performance is to see picture performance in pause. First EP, now in SP. The rolling bar in the picture does not actually exist. It's an artifact of photographing a television screen with a television camera. Notice that the double azimuth picture is noiseless. The reason for this is very similar to the helper head concept in 3- and 5-head machines. Now, in a double azimuth VCR, the helper head for special effects playback is borrowed from the second set of heads not being used in that speed. Now, a benefit of this system comes in the form of noiseless special effects, such as picture advance and slow motion. Notice how clear and noiseless the effect is. It's this kind of picture quality that helps Zenith customers understand the value of Zenith performance. Now, from what we've shown you, it's obvious that picture quality is closely related to the number of video heads available for recording and playback. And we know, for example, that 2-head VCRs are designed for optimum performance in the EP tape speed. And we know that 3-head machines generally outperform 2-head machines in special effects modes. Now, in addition, we know that 4-head VCRs are designed for optimum performance in both tape speeds. But as you step up to the sophisticated performance of 4-head double azimuth and 5-head designs, it's important to remember that actual differences can be very subtle. So, in the final analysis, it's not simply a matter of more is better. It's finding out just how much performance your customer really needs and wants. Our discussion to this point has been on video recording. But today, head count is not limited to video alone. To see how audio can impact on head count issues, let's first look at the different types of audio. Currently available audio formats on VHS are longitudinal mono, longitudinal stereo, and hi-fi stereo. Now, depending on the model, each of these audio formats can be found in Zenith products. Let's take a look at how audio signals are recorded. Now, in longitudinal audio, the sound is recorded by a stationary head. So in this configuration, the audio head is not part of the head count because it's not mounted on the rotating head drum. Now, as we can see in this model, longitudinal audio is recorded here at the edge of the tape. This area is used for mono as well as linear stereo. But hi-fi represents a very different approach to where and how the signal is placed, and a very different sound as well. This model will help explain. To achieve hi-fi stereo, 2 audio heads are mounted on the rotating head drum. Now, this allows the audio heads to use almost the entire width of the tape to record the hi-fi audio. Now, these hi-fi audio tracks are recorded here, deep within the tape, and the video tracks are recorded over them. Since hi-fi audio heads are on the drum, they're usually included in the head count. And this brings us to an important point. The distinction between the number of audio and video heads should be made clear to the customer. This is because it is possible to have a 4-head hi-fi stereo VCR where 2 of the heads are for video and 2 are for hi-fi audio. So in terms of video performance, this is still a 2-head machine. Now, the difference between longitudinal audio and hi-fi stereo performance is evident when you hear it. Now, here's how we explained VHS hi-fi when it was first introduced.
Advanced hi-fi technology opens a new world of home entertainment. Conventional left and right channel longitudinal audio is recorded onto the narrow edge tracks of the tape. But hi-fi performance comes from 2 separate flying audio heads that record stereo sound over the full videotape width, the portion traditionally reserved for video signals only. The sound is laid down first, deep within the tape. Next, the video heads put down a picture signal. This is depth multiplex audio FM recording. The result is VHS quality pictures with sound performance that approaches the finest digital recordings, an effective audio writing speed of nearly 230 inches per second. Television and music have just taken a quantum leap.
As we mentioned in the program on understanding stereo, the reason for this difference in performance is a function of speed. Now, in general, higher head-to-tape speed during recording means higher quality. Tape speeds range from less than ½ an inch per second in EP to about 1½ inches per second in SP. Now, in the world of audio recording, this is very, very slow, and longitudinal audio is recorded and played back in this way. But hi-fi stereo recording involves a different process. Since hi-fi audio heads are mounted here on the main head drum, which rotates at 1800 RPM, they're laid down here on the tape. Now the effective recording speed is equivalent to 230 inches per second. Now, it's important to understand that this does not mean you're using more tape to record hi-fi audio. It simply means that if you laid each one of these tracks end to end, the total length for a 1-second recording would be 230 inches. It's this dramatic increase in speed that generates sound quality rivaling that of CD audio discs. So, to recap, the head count story is in essence a story related to both video and audio performance. Understanding the technology will help you to match product to customer expectations. And that match will generate sales for you and satisfaction for your Zenith customers. Now, since this program has been an overview of a technically complex topic, carefully review the chapter on VCR head performance in your InFocus training manual.